Hello, Wizards here. A while ago, a TryHackMe CTF took place. It was called Hackfinity Battle, and today I would like to solve with you one of the challenges. To be more specific, a reverse engineering challenge. This first one, today, is called Compute Magic. You need to start a machine, and yeah, we managed to gain access to one of the Phantom servers and recover binary that computes data. Discover how it works to get the flag on the remote server. Okay, we start the machine. It's going to start for a little. Right now, I can tell that I have this binary downloaded here with some dummy flag and one file that's gonna be useful later on. Okay, divide terminals. No, thank you. Sudo switch user. We'll need to connect the machines, so we need the VPN. Let's go to documents, reversing one, copy paste it here as well. Now if we click at file, we can see this is an ELF binary, 64-bit, LSPy, dynamically linked, not stripped. So all the information that were left there, it still is there. Also it's an ELF, so it's a Linux executable, not Windows one. I have it in ghidra imported. First you need to create a new project. I call it my YouTube ref. Then you click file, import file, or just click I, choose the binary and double click on it so it opens a code analysis. Yes, it has not been analyzed. Exactly. Yes, we want to analyze it now. Analyze, let's go. As you see, a bunch of assembly appeared and it got us to main. This code will look a bit scary because this is pseudo-c, which is called. Which means from this assembly, ghidra will try to change it and translate it a little bit into C. It sometimes fails, sometimes it's good. In this example, it's a pretty alright representation. Alright, let's go. There is a bunch of different variables. We don't know what they do yet, but we can figure it out from the code down below. First, we create a socket, so we can click L to rename it socket. Just click socket. Then let's go down. Okay, there's some IVAR, okay. This isn't very important. Some accept, then we start with send banner, which probably sends us, compute some magic. That's really about it. This is going to be a socket, and this is going to be a buffer of size. Compute some magic needs to be specified, because this function, right, needs to have specified what's the length of the string. So right here, we can rename this also with L to length, or maybe buffer length. Perfect. Nothing really more important here. Then we read our input. Local 28 is the most important one because it is going to tell us this is our password. It's our token passed. And this is also the length of the buffer, which will for sure be, that's small 16. It means our password is 16 bytes. Read flayed, okay. So this would probably be read error code. Then they get passed. Okay. We need to change it to pass length, because as you see, str length gives us the length of a string. Just password. Okay. Here they're probably adding this null byte for termination, and then they check it with spell check. Local 48 is our socket, and this function is really important and really interesting. We can also name it like probably this is going to be a stream, so it's going to be input stream. I think I can call it this way. Otherwise, fix my mistake in comments. Thank you in advance. Okay, check spell. Here we get two parameters, char and some undefined, and a very big if-else case. First, let's rename those parameters because param1 and param2 tells us probably nothing. This is strlen, So first pointer, as we've seen before also, it is our password. And the second one must be a socket. Yeah. Then this is going to be our len. And UR, what is UR? We can scroll down there. It's probably a status, like is correct. Perfect. I've analyzed it before, so there are like types of functions. First one is going to change it into magic fail, and it's going to just call it and say go back. Nothing very important. Okay, and let's go further, because here we have two interesting functions. Function 13 is interesting, but we're going to probably be looking more at the same one, which is function 8. Yes, it takes two parameters as we established. Socket first is password, and second is socket. Then it checks other password, they're probably against something, and if the status is correct, then it reads the flag. Let's try this check other. Okay, a bunch of different things here. Let's get changed into password as well. And now here, this is going to be our I. Because as you see here, it's only in the for loop. It's going to be I. Also running through 16, which is 16 characters. And then here's something interesting happens. Because for every single character in password with added offset, right, they add 4 to it and XOR it with the value 13. And they change it into character again and save it into encrypted string. I stood here for a while and thought about what to do with it. And in the end, I've created one Python code, this decode.py. And you see here, if we want to encrypt something, we turn to a character, a ASCII code of a character, add 4 to it, XOR it, and they turn into character, as I mentioned. Yeah. Otherwise, for decrypting, you take a ASCII value of a character, XOR with 30, and -4. Why we can XOR it? Because XOR is reversible. So if we write 13 XOR 3, if we equals something, if we XOR that value, it's going to be the same. Let's actually try it. We go to cyberchef.org. Let it load for a while. Perfect. It's going to take some time to work. Here it is. We can search for XOR. And if we take, for example, value 13 and XOR with key 2, it's getting 31. But if we take 31, it's 13. You see? It's reversible. Okay. Now we have this. We have our code. So we can try to take this flag, because that's exactly what happens next. We take the encrypted string, we turn it into a string value, and compare it with this a flag 15 something. If it's the same, again, it's correct. We pass incorrect. If it's correct, we pass correct. So let's go back, and now try to analyze read flag, just for the sake of analyzing it. Okay, it creates RSS stream where it opens a file, if it's alright. Then they read the contents into a file. It is 1024 bytes. Let's change it to flag contents. Then we send it to the socket and check did send. Not did send, it was sent. Then we just close the file stream and we're good to go. Okay, that's about it for this time. Let's go back to our check other function, copy this part, and run Python code. We're going to need to encrypt this and pass the string. But technically, if we were to decrypt as well, then it will give us the same flag. Okay. I just don't know how to XOR properly. And this is what we need to pass into the remote so we can XOR flag. Okay. Netcat, paste the AP, compute some magic. Oh yes, we will. Copy, paste, enter. Okay, probably did not take the additional space there. Perfect. Some magic can be computed. Is that the flag? Yes, it is. So, thank you so much for watching. I hope you enjoyed this little write-up. If you want to learn more, just type in the comments. Leave a like, subscribe, and you can see more reverse English channel. I will probably upload today Old Elf as well. So, we'll see. Thank you again. See you next time, and cheers.